Let us start by looking at the given. First, we are told that P starts out at the origin O. Now, P moves in a straight line, and the number of units that it moves depends on the result of a die throw. The die is considered fair, so that means the numbers on the die, 1, 2, 3, 4, 5, and 6, all have equal chances of coming out. And we are told that P only moves in a straight line, so it can either move forward or backward in the positive direction or the negative direction. And which direction it moves is determined by the score we get on the die throw. For example, if we get a score of 6, what happens is that P teleports back to the origin. That means if you have this number line here and your die, let's say it starts at the origin, so it starts at O, and then for some reason it's now at 3, for example, and then the next time you throw a die, a 6 comes up. So what will happen is your point P will teleport to the origin O. So it doesn't matter where the die is. So long as you get a 6, it will teleport back to 0, to the origin. Okay, so that's the first 3 conditions. Those are the first 3 conditions. Now, we are also told that if you get either a 1, 2, or 3 in your die, you're going to move to the positive direction 1 unit. So for example, at the start, because the point P starts at the origin O, if you roll on either a 1, a 2, or a 3, that means you're going to move to the positive direction by 1 unit. That means you're moving this way, right? Because in this number line, we decided that this will be the positive direction, this will be the negative direction. Okay, now suppose you get a 4 or a 5, then P will have to move backwards to the negative direction, and that's by 1 unit. So suppose that P is now at 2. If you roll a 4 or a 5, it will have to move to the left by 1 unit, so it will now be at 1. Now, to understand this better, we have 2 examples here. So there are 6 rolls of the dice. So on the first roll, for example, there will be a 1. So in this example, first example, so let's satisfy the first condition, which means that P will have to start at the origin 0. Now we roll a 1. What will happen when we roll a 1? Because 1 here means that we have to move to the positive direction by 1 unit. What happens is your P will now move this way. And now it's going to be at 1. The next time you roll, you get a 2. But if you roll a 2, again, you move to the positive direction by 1 unit. And so because you started here, now you're going to have to move this way, and now it's going to be a 2. Now you roll a 3. Because 3 tells us that you have to move to the positive direction by 1 unit, then it will move this way, and now P will be at 3. The next time you roll, you get a 4, okay? But now, if you get a 4, you have to move backwards by 1 unit. And so we were at 3, and now we have to move backwards by 1. You end up at 2. And the next time you roll, you get a 5, okay? Now, 5 tells us that we'll have to move by 1 unit again, and that's backwards. And so we'll have to move this way. Now, P will be at 1. And finally, you roll again, and you get a 6. But what do we know about 6? 6 says that P will now have to teleport to the origin. So wherever you started, it will now have to teleport back to the origin. Okay? So with this example, we know that at the end, because we get a 6, point P will be at the origin. Now let's take a look at another example. So again, we start at the origin because that's given. We start at O. Then the first roll, we get a 1. Okay, when we get a 1, that means we have to move forward by 1 unit. So we move this way. Then we get a 5. But 5 tells us that we have to move backwards by 1 unit. So we're back to the origin. Now you roll again, you get a 4. 4 says move backwards by 1 unit. So now we're at -1. You roll again, you get a 3, and 3 means you have to move forward by 1. So we're now back at 0 at the origin. Now you roll, you get a 6. 6 means we teleport to the origin, and so nothing happens because we're already at the origin. We teleport to the origin, nothing happens. We're still there. And finally, we roll a 2, and 2 tells us we have to move forward by 1 unit, and that means we'll end up at this position. So after all 6 rolls, we will end up at 1. So that is what the problem means. That's the situation that the problem gives us. Now, the question the problem asks is the following. Suppose you throw the die 4 times. So here we throw the die 6 times, but now the problem is only asking about the situation when we are rolling the die 4 times, okay? What is the probability that the point P will be at 0 after the 4th throw, okay? So we want to know what is the probability that we end up at the origin after the 4th throw. Okay, so first, let's plan this out. What do we mean by probability? First, let's recall that probability means that it is the number of ways that an event could happen divided by the number of all possible ways. So in our problem, in the numerator, the top part of this, we're looking at all the ways that the last throw, that is the 4th throw, lands the point P at the origin O. So we're going to have to look at all of those possibilities. And in the denominator, we're going to have to count all the possible outcomes, all the number of all possible outcomes for which, for when we throw 4 times. Okay, so to know the value here in the numerator, we will draw a tree diagram. Okay, we're going to look at all the possibilities. What if we start with a 0, a 1, or a -1, right? So all of those. And so we're going to have to draw that. And then when we have that drawn, we're going to count the number of ways for which we land P at the origin after the 4th throw. So that's what we're going to do. And that's going to be our numerator. So we're going to have to find that out first. And then we're going to have to determine the denominator. But the denominator is quite easy to determine because we have 4 throws. So there's going to be a first throw, second throw, third throw, fourth throw. And for the first throw, there are 6 possible outcomes, right? It's 1, 2, 3, 4, 5, 6. All the faces of the die have equal probability of getting rolled. So that's 6 possible ways on the first throw. On the second throw, there are also 6, right? Nothing happens to the die. On the third roll, there's still 6 possible ways. And on the fourth roll, there are still 6. So if you multiply those out, you're going to get 6 to the 4th. And this is going to be our denominator. There are 6 to the 4th possible outcomes for 4 throws. Okay, now we're left with just task number 1 and number 2. First, let's draw a tree diagram. So it's easy to start at the 4th throw because we know where we want to be. We want to be at the origin, right? So it's easy to start there. And then we move backwards. We work backwards, okay? Now, let's start when, so if we recall, there are only 3 possible moves, right? So let's look at that again. Either you teleport to the origin, or you move forward by 1 unit, or you move backwards by 1 unit. Okay, so those are the only 3 possible moves. And here we write that down. We've got 0, which means here we mean teleport to the origin, 1, which means you move forward by 1 unit, and -1, which means we move backwards by 1 unit. Now, if we start with 0, okay, sorry, if we end with 0, that is the 4th throw. If the 4th throw is 0, that means we will teleport to the origin, right? So it doesn't matter where we were, on the third throw, on the second throw, or on the first throw, they all do not matter. If we land a 6, or if we land a teleport to the origin move on the fourth throw, all of these do not matter, right? So that's why we put an X there. X means we don't care, we don't care, we don't care, okay? As long as we get a 0 on the fourth throw, that's gonna land us at the origin. So that's good, it's easy when you get a 0, when you get an origin, teleport to the origin, which means it should be a 6 on the die, right? A 6 on the die. So that teleports us to the origin. So that's now taken care of. Now, what about this move, moving 1 forward? Okay, if that was the first, or rather the fourth roll, if that's the outcome of the fourth roll, what possibilities could we have on the third roll? So again, there are only 3 possibilities. Either we teleport to the origin, we move forward, or we move backwards by 1 unit. Now, let's look at moving backwards first. So if we were already on, if we already got a move forward by 1 unit on the fourth row, and we got a move backwards on the third throw, they will cancel out, right? 1 minus 1, you get 0. That means it is as if we ended up where we were on the second throw, right? Because the third and the fourth throw will just cancel out each other. So that means we're only interested in looking at the second throw, okay? So again, we write down -1, 1, and 0 for the second throw. Let's look at the possibility when we get a -1. That means move backwards on the second throw. What should have been the first throw if that's the case? Now, in this case, we don't care about the fourth and third anymore, right? Because we said they cancel out because it's 1, -1. So we're only interested in the second throw. Now, if you got a -1 in the second throw, your first throw must be a +1, right? So that they cancel out, because we know that P starts out at the origin. So if they cancel out, that means P will end up at the origin. And that's why we are forced with this one, right? This is the only possible first throw if the second throw is -1, right? Because, for example, if the first throw were 0, right? If you get 0 here, that means your second throw would have you at -1, right? Which is not the origin anymore. So that's why we don't want that. Also, if you have a -1 on the first throw, on the second throw, you get another -1. That means you'll end up at -2. Again, that's not the origin. And that's why we don't care about 0 and -1 here. They're not part of the possibilities. There's only 1 in this case. So this is taken care of. So that's good. Now, let's look at the second possible option here. If on the second throw, again, remember, we don't have to look at the fourth and the third throw in this case anymore because they cancel out. That means we are left with the second throw. Wherever we are after the second throw, that's where we will be after the fourth throw, because the fourth and third cancel. Okay, so now suppose that the second throw we get a +1. All right, that is move forwards 1 unit to the positive direction. The first throw could only be -1, right? So that they cancel out. And that means we end up at the origin because, well, P starts out at the origin. And if they cancel out the first and the second throw, then we still end up at the origin. You cannot have 1 here, again, for the same reason that we couldn't have -1 here and here, is because if you had 1 on the first throw and another 1 on the second throw, you end up at 2, right? That's not the origin. Same reason why you don't want a 0, because if you had a 0 or origin at the first throw, then after the second throw, you're going to end up at 1, right? So the only possibility here, if on the second throw you got a 1 here, the only possibility is that for the first throw, you must have a -1. Okay, good. Now, for the second throw, if you get a 0 on the second throw, that means you're already at the origin. So that's good news. That means you don't care about the first throw anymore, right? Wherever you are on the first throw, because the second throw tells you to teleport to the origin, that's going to be okay anyway. And you don't care about whatever is the first row, okay? So this takes care of this first part of the tree diagram. Now, we still have 1 here. So if you've got 1, 1, so that means you're moving 2 units forward. So the only way you could be at the origin is to move 2 units backwards to the negative direction. And that's why you need to have -1 and -1 here. No other way, okay? You cannot have 0 because you won't end up at the origin. These 1 and 1 should be canceled, right? +1, +1, you should have -1 and -1. You cannot have 0, you cannot have 1 in here, right? And also, it's worth mentioning, you cannot have 0 on the 3rd row, because if you had 0 here, that means you are now at the origin on the 3rd row. And when you roll a 1, or a number that makes you move 1 unit forward, you'll end up at 1 and not at the origin. And that's why we cannot have a 0 here on the 3rd row if we want a 1 on the 4th row. We do the same analysis for -1 on the 4th row, and I'll let you do that on your own. And if you don't think it's correct, the one I did here is correct, let me know in the comments. But yeah, it's worth doing this on your own. You're gonna absorb it more when you actually do it on your own. So for now, trust me that this is gonna be what you're gonna get. This is gonna be the tree diagram that you're gonna get. Now, we're going on to counting. Okay, we're gonna count how many possibilities are there, how many ways are there in this tree diagram where we get what we want. Okay, so for example, in how many ways can we get a 0? When do we get a 0? That is when we roll a 6. Remember, you get a 0 when we roll a 6. You get a 1 when we roll a 1, 2, or 3, right? That means there are 3 ways to get a +1. And there are 2 ways to get a -1, right? It's 4 and 5, okay? So when we come back here, we can say that here we only have 1 way. Here we've got 6 ways, right? Because we don't care. X means we don't care whatever it is. Here we also get 6 ways, and here we get 6 ways, right? And if you multiply them all out, that means for the first line, we get 6 to the 3rd, or 6 cubed possible ways, okay? So we're gonna write that down. It's gonna look like this, okay? You start out with 1 possibility for a 0. Now you multiply it with 6, so you get a 6 here. You multiply it with another 6, you get 6 squared. You multiply it with another 6 possibilities, and you get 6 cubed, and that's why we get 6 cubed here, okay? Now, look at this. We said that to get 1, you have 3 possibilities, right? Now, here we have -1. How many possibilities are there for -1? Okay, there are 2. So 3 times 2, we get a 6 here. Again, -1, that's another 2 possibilities. So we get 6 times 2, so that's 6 times 2 in there. And again, we get a 1 here, which gives us 3 possibilities. So 6 times 2 times 3 is going to give you 6 squared. Let's do one more, okay? So again, we had 3 here, and then here we had 6. So let's start here because we've already done this computation. 6, and then how many possibilities to get a 1? You get 3, so 6 times 3. Then you get another 2 possibilities for -1. So 6 times 3 times 2, you get 6 squared again. And then you can do that for all the rest. Okay, you're gonna see that all of them actually gives you 6 squared. Now we are ready to count all of these, right? All we're gonna have to do is add them all, okay? So we have a 6 cubed here, so we get a 6 cubed. And then let's count, how many 6 squared do we get? We get 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. So 6 squared times 8. Okay. Now, we also already know that the denominator is 6 to the 4th, right? So when we compute the probability, which is just the numerator divided by the denominator, we copy the numerator here. We copy the denominator here. We see that the 6 squared cancels with the 6 squared in the denominator. So this one becomes 6 squared. This one becomes 1, and this one just becomes 6. Okay, so what we get in the numerator is 6 plus 8. In the denominator, it's 6 squared. We get 14 over 36. And if you reduce that to lowest terms, you get 7 over 18.